Sorry to interrupt the chill lo-fi music here, but we are ready to start today's little course on advanced data visualization. Today, we'll talk about a few different topics, and we'll have sort of like a current event section because there's a new thing that I wanted to show you that's just relevant for something we talked about last time, and I will get to that in a second. But we'll talk about a few different topics here that are actually planned, and those include presentation and a little touch on sort of storytelling, which is a term that I need to be careful with not to go into too many long rants about because I have some opinions there. But I will talk about a few ideas around, or very, very, very simple ideas around how to tell better stories in a presentation with data. And then we'll talk about well, first of all, we'll talk about uncertainty in data, or in data visualization, I should say. And I'll show you a few ideas there that I think are really interesting. And it also are interesting because they are sort of, they go against our perhaps way of thinking about uncertainty in some ways. But there's really interesting research about that now, how to properly show uncertainty in data viz. And then in a somewhat related way, we'll talk about Simpson's paradox. And I put it in air quotes, and you will see why, because I don't think it is a paradox. And it's actually important to realize that it's a thing that really exists in a lot of data analysis. And then finally, we'll talk about unit charts and ISOTYPE. That will be fairly short, but we will be hopefully getting to that because I have a fair amount of stuff to cover. All right, so with that, let's just get into it. Hello, everybody, saying hi from Argentina and North Carolina and all kinds of other fun places, I'm sure. So let me switch over to this view. I'm going to scoot over here a little bit. So the first thing I want to show you is, this is the current event section. So there's a new framework for scalable data visualization that I wanted to show because it has some interesting features that I think are relevant for the discussion on interaction from last time. And it's also built on top of observable plot. So it's actually quite interesting. This is work by the University of Washington Interactive Data Lab under Jeff Hare. And so he's, of course, aware of observable, which is done by one of his former students, Mike Bostock. And plot is part of observable. And so anyway, so this toolkit is built, is another grammar of graphics, another one that is, in this case, based on plot, which is a grammar of graphics, not the grammar of graphics. And this one has an emphasis on being scalable to large amounts of data. And so there's a lot of tricks that you can use to not draw a lot of things when you don't need to draw them. This particular example doesn't really show that, but I wanted to show it anyway because it's actually more interesting here for interaction. So this is a data set about 1 year's worth of weather in Seattle. And they have these different categories here. So there's, for each day, there can be several things happening, which is actually quite common in Seattle. So there can be sun, fog, drizzle, rain, and snow. And so at the top here we have, and then there's also the temperature. So this is temperature here, and then this is just the time axis. And we can do two different interactions here. We can brush. I'm just clicking. Whoops! I can click and drag. And that way I can select a date range. So I can select roughly a month here. And so that selects those points. And as you can see, this is highlighting now. So this is brushing because it highlights. And it also highlights the bottom bars. So you can see that this is sort of a fraction of each of those bars being shown. How much of that section here is the total, is the fraction of the total for each of these categories. And as I mouse over here, you can see that it rains more in the winter, which isn't surprising. And then in the summer, we get more sunshine than rain. So all the people who think that it always rains in Seattle, it is not the case. It's actually quite beautiful today, if you see out my window here. And then we get back into the winter and it gets rainy again. So you can do this selection here, or this brushing here, which is a selection, or a highlight, I should say, which also selects, I guess. And then down here, we have these bars, and the bars act as filters. So when I click on a bar, you can see that it just highlights the whole bar. But at the top view here filters. So I lose the context in this case. So I'm losing all of the other points that aren't the one that I'm clicking on. So this, is an interesting way of doing things. I would probably have done this as a highlight in the top and not the top view, not a filter. But it's interesting to see that you can combine those, and you can actually you can do whatever you want. You can try different things that are quite interesting, and see if they work for your particular use case. So that's one example here of interaction. Another example here, and this is basically the same but that you saw earlier, that you saw last time, I should say, when I looked at the cross-filter example. This is now cross-filtering across a larger amount of data. This is 10 million rows, which is why it's not showing the list at the bottom, because that would be hard to do in the browser. But they know that we're only drawing bars, and because we're only drawing bars, and we're drawing maybe a few dozen bars here, the drawing itself is actually really easy. But the key issue here is to do the filtering on the data, and then do all of these the data processing on 10 million rows in the browser, which a few years ago would have been, I mean, it's still actually quite impressive. It's just too easy to just assume now that we can just do anything in the browser. But this is still quite impressive that we can even load this much data, much less that we're able to interact with it without seemingly any lag, because this seems to be extremely fast here, even though I'm even streaming on the same computer and everything. And we're seeing the same pattern we saw last time. So this is that flights data where we have the delay here on the flight delay from 0, to the left being early, to the right being late, and then this is the number of flights over the day. So this is the hours from 0 to 23, and then this is the distance of the flights. And I'm just going to show you this pattern again. That's quite interesting, where the higher up you go, the more you get this pattern of going later into the day. So the later in the day, the more delays you can expect. So another example of that kind of interaction, the cross filter. And then this is just another example to show this is a large, well, in this case, 5 million rows, again, large data set for the browser, just to show a different kind of interaction or a different kind of view. This is now a dense plot. So these are obviously bar charts down here. This is about a star catalog. I don't know very much about this data set, but it's looking at the catalog of all the known stars, and there are apparently 1.8 billion of those now that we have cataloged. And there are all kinds of measurements that we have for them, of course. And so there are some things here, like I think this is the magnitude here of those stars, meaning how bright they are in the sky, and then the where they are, the parallax, and then I don't know what these other things mean, but you can brush over any of these, and that makes a selection in the other charts as well. And so we're brushing over, I don't know, we could brush over this particular space here and see what that looks like in terms of like magnitude, or this here. They don't look all that different to me, but perhaps this chart here is an interactive chart. It's more of a scientific visualization type of thing. And I think I'm seeing a question here. Oh yes, so the URL this is all linked to from the notebook, and I think I don't know, maybe Paul can post that link to the notebook. So I have a notebook that has the let me see if I still have this here. Actually, I'm going to post this right now. Okay, there you go. So now I have to link twice. Sorry about that. We were going to post it. So there's the write-up, of course, a notebook that has all of the links to all these things, so you can play, but not during the class. Okay, so I just wanted to show you these things because this is interesting and a new thing to play with, especially if you want to try out these large data sets interactively. All right, and I didn't actually want to spend that much time on it, but so let's talk about the next topic, which is presentation. Let me see if I have my focus here. There we go. Okay, presentation is the next topic, right? So this is actually a very brief recap from the fundamentals course that where I talked about presentation and exploration of what that means. And maybe I'll zoom in here a little bit. So this is also linked from the write-up for this lesson to link back to the previous notebook that talked about this. But very briefly, I just want to talk about a distinction that I think is really important. And that is that there are basically 3 different types of context of work in data visualization that I think we need to understand as being distinct. And so this little write-up here is basically talking about what they are and how they are different. And so my main point here is to say that there are these three. And so the first one is I call exploration and analysis. And the idea here is that you have a new data set or something that you're unfamiliar with, and you have to do the analysis where you're asking lots of questions, where you sometimes you have specific questions, sometimes you don't, but it's an early exploration. You don't tend to create very fancy charts. You usually use a lot of bar charts and line charts and things like that that are just useful because they give you a quick idea of the data, and they're generic. So they work for pretty much every data, and they're not meant to be special. They're meant to be simple tools that give you a quick answer. Then we go on to explanation, which is about helping other people understand the data. So now you're talking to other people, and usually what people tend to do is they show them everything they've done. And that is just another very good way of doing things, because you tend to just bury the interesting bits in all the stuff that you have. So it's really important to curate that and to just narrow it down to just those things that are really important, to show people those things that are the key, that you really want them to know. It can also be useful to sequence things and sequence them differently from what you actually did, because the story of like how you found things isn't very interesting to most people other than yourself. And another point also, it's very useful often to add interaction. So that's why interaction is of course an important topic to talk about. And then the third one is, so the explanation part is sort of like in the middle, and so that's where it's harder to delineate it precisely from sort of the first and the third of these kind of categories here. But it tends to be smaller groups that talk to each other and that have more of a shared understanding of data or of the topic of some sort, like a business context or whatever, where people are experts in their fields and in their context, and they want to know what's going on. And then there is the presentation. And presentation is, again, very distinct from the first two. And the point here very often, or the point should be, to walk your audience through an argument and help them come to a decision. And this is about efficiency. This is really about how much can you support a decision by being able to, sorry, I just read a comment here about wanting, somebody asked me to rant about storytelling. I will get to that. But so presentation is really about supporting a decision-making process, or somebody who doesn't necessarily know all the nitty-gritty of your data, but who needs to understand the key things that are in there. And so there you want to add more explanatory things. This is also where news graphics are just really interesting sort of references, because they tend to walk you as a non-expert through data that was collected by somebody who spent some time figuring out what's in there. And there it's also important to really tell a story. And I'll get to the storytelling part in a moment, but to essentially, at least, to not just present a bunch of charts, but to have a reason why they are sequenced in a certain way, and to have a point at the end. And in the first course that I talked about this, I got a lot of pushback from people saying, well, but now you're biasing people and so on. And that's not what this is about. Of course, you're trying to be certainly honest about the data. You're not trying to push your point of view. It always has to be rooted in the data. But you are also showing, you're expressing a point of view. And that is important. I think it's really easy to underestimate the importance of that, because that is actually the value that you as the analyst, as the database developer, as the database designer bring to the table, because you have understood this data. You're bringing your natural intelligence to this that isn't just the data analysis steps that have happened. So there is the human layer on top that is very important here. And this is also why data viz is such a messy topic, because we can talk about grammars until the cows come home, but the grammar is only ever going to cover a very small part of the data viz process and the value of data visualization, because the real value comes from data viz being used for communication and for presentation. And so that's why I think this is a really important topic to talk about. All right, so what I'm gonna do here, if I can find my notes, is to talk a little bit about a couple of things that we found in in a study that we did a few years ago, we being my former colleague Matt Bremer and I, on people using data in organizations when they basically, or in meetings, I should say, in organizations. I'm just gonna. I didn't feel like it made sense to make slides for this because there really aren't enough points here, but it's essentially, this is going to be essentially slides. And all of this stuff is in the write-up. So I'm just going to paste this in here as bits of Markdown and then talk about it briefly. So the first point here is that people, and I was going to paste this one here too. All right, so one thing that happens is that people tend to use a small number of charts for their analysis and then bring those charts into presentations. And that can be the way to go, but it often actually makes for just very boring and very hard to remember presentations because you're not able to really get a point across that way. So here are a few quotes actually from this study. Somebody was saying, like, they notice that people are sometimes half asleep. Or they notice that they're like doing stuff on their phone because they're looking off the screen and they're apparently doing things. And so it's like, sure, people just tune out. So if you're using the same thing over and over, people are just not going to be paying as much attention as if you have something unusual, which I'll get to in a moment. There's another guy who was really interesting. He was saying, I hate bar charts. They're very 2001. I don't know exactly what that means, that something is very 2001. But bar charts, again, are extremely useful. But they are also used for everything. And so if you want something to stand out, to be more interesting, then you're going to need something else. And so some other person, I think, said that they are using lollipop charts, which is basically just a very thin bar chart with a little dot on top. And so there's basically a dot plot combined with a very thin bar chart or a line chart, a line chart as in a vertical line that points to that point. I was saying, well, I use these to break up an otherwise boring series of charts. And lollipop charts are, as charts go, they're fun and they work pretty well because you can reasonably, you can read them fairly well. The lollipop makes it a little bit harder. I mean, the top of the circle makes it harder to precisely compare values, but that's usually not the point anyway. And so it's a good idea to break things up a little bit, to have something that stands out. And so that's really what this was about, is that people wanted to find something that was a bit more interesting and unusual. And I'll get back to this in a little bit, because I'll be talking about ISOTYPE later and unit charts, and those are a way to make things a bit more interesting. I also have a paper that I linked, I think I did, yeah. So in this case, I'm linking to a few things that I've done in the past, papers or blog posts that talk about these things, because I have a little bit of a history there, and I think this is relevant. But basically, that there's a little bit of an opinion piece that talks about different types of charts being used for different kinds for different purposes, and that's really what that is about. So unusual charts, and again, some of those I'll get to today, and then we'll also talk about the connected scatter plot next time. Those help because they just make things a bit more fun and more memorable. That's really the thing that I think should sell this. The other thing that's really interesting that is kind of surprising to me, that this isn't really getting more attention, is that meetings don't just exist in a vacuum. I mean, sometimes they do. Some meetings are just one-offs, and that's it. You present something, you never talk to these people again. But for the most part, meetings are recurring. You have a meeting every week. You have a meeting every month, every quarter. You have business reviews. You have all sorts of things that happen on a regular cadence. And so when you go into those to present data, you're not starting from zero. So, but a lot of presentations do that. A lot of presentations are essentially saying, this is like, here's where we are, and it's totally disconnected from everything else. And that's really interesting that people do that, and some people sort of complain about that in that study too. But it was something that people just do because they essentially take off their analysis and put it in their presentation, and then of course you end up with a ton of stuff that doesn't know anything about what happened before. So you want to make sure to be aware of that. Well, you should be aware of that, and you should actually make use of that by building on what was discussed last time. And this can be tricky, of course, because not everybody might have been there. People might not remember, so you want to remind people, but you want to make sure that you show what is different, and that's a different way of showing data than just showing the numbers. And this, of course, and I wanted to talk about audience here, but I cut that part because I thought it was just gonna get too long. But you have to basically think about who is your audience, what do they know, and what are their needs, what are their questions. And some people have very specific ideas of what they want. They want numbers, or they just never remember what happened last time or whatever. So you have to take that into account. But you can also go the other way by just boring people, by showing them things that they already know, and then this is gonna be zoned out at the point where you're showing the new stuff. So it's really an important and very kind of difficult line to kind of straddle, to go between being boring and just not having enough context. So you have to think about who the people are that you're talking to, and what they need and what they want, and help them and give them the information that is tailored to them depending on that context. And because these things again happen in some sort of series, it's just it really helps to keep that in mind and just be aware of that, and that alone is going to make presentations better, because you're going to be more aware and more thinking more about your audience and actually building things for them rather than building something that you think it would be interesting, which can be quite different. It can also be the same. I mean, it depends very much on your sort of where you're coming from. Then my next point here is to talk about these different functions of meetings. So one thing so this paper that I linked to that talks about that, we call this the from jam session to recital, and this is sort of like playing on some music metaphors to describe the kinds of things that you would be doing in different kinds of meetings. So the first one is the most informal one, and we call this the jam session. And these are very often not really they're certainly not formal presentations, and the presentation part very often there is just the starting point for a discussion. So you're usually talking to your peers there. You're not talking to people outside of your group. And often the presentation just kind of is to get everybody on the same page, or to give everybody a sense of what's in the data. So we talked to several people who do this, who are responsible for sort of like ingesting data at first, and then figuring out what the first sort of like to get a feel for what's there for a new client, for a new project, and then ask the common questions, and then present what they found, and get a feel from their colleagues, like what else is there, or like a read from their colleagues, what else do they need, and then they might just do it right there, because these are often working sessions, which is why we call them jam sessions. Or they might just say, well, okay, I'm going to have to come back and maybe find some other data or something from the client, or whatever it is. But these are very interactive, and they are much, and in this case, you are certainly much more going to use your bread and butter charts, like bar charts and so on. Then the next step sort of up from that is what we call semi-improvised performances. So this is a bit like a jazz concert, where you might have a part of it prepared, but there is improvisation on top of it. And so this is more of the presentation that is outside of your immediate group, where you talk to people who are maybe your superiors, people who are outside, who are the kind of the stakeholders in a larger organization, but they are still very familiar with the data. So these are people who know the numbers, who know the business or whatever it is that you're talking about, who have very specific questions in mind about what they want to know to do their jobs. So they are you're perhaps a data person, but these are the people who are making the decisions, or who are I don't know, who have all kinds of questions to base their work on. And in this case, you're going to have a more formal presentation, as in you're going to have more of a story to tell, but you also have to be prepared for lots of questions. And so now you're going to get into there will be interaction, there will be questions, and you will probably have to either have to say, well, I can get back to you on that, or be able to do it right there. Perhaps if you have that stuff prepared, it's actually a very good thing to have. It's very impressive usually to have slides. If it's slides, and it probably is slides because everybody uses slides, but whatever. So slides prepared that have common questions on them already. So if you know that somebody's going to ask a question, you can say, well, I have a slide for that. And so that can be a good thing, a good way to impress people there. And of course, also to be prepared for that kind of question. But here you want to tell more of a story, but it's not as critical because people are going to pick your bits apart and your data apart anyway, and are going to ask very, very detailed questions probably. And then the last one is what we call the recital. So this is it's like a concert, a classical concert, like a big thing where everything is like has been rehearsed to death, and like everything's going to happen, and there is no interaction, or almost none. And this happens when you talk to an audience that knows little about the topic, but maybe a large audience, like a big talk or like a TED talk, this kind of thing. But also people who might be making important decisions based on what you're telling them, but without being very involved in the actual data. So this depending on on the kind of organization you're in, this might be a board, like a board of directors. They might not be very involved in like the little details, but they might be making very big kind of overall decisions. Or it might be a presentation we talked to somebody who works in some kind of it's like a trade organization, and so they do presentations to a large number of members of that organization, and those are important presentations because they are like for accountability and so on. It's a big deal. Like they get prepared over months, but the audience isn't going to know all these numbers, but they want to know, so where are we relative to where we were and things like that. So they want to be told a story about where they are. So there's going to be a lot more preparation of that kind of thing. Right, and so especially in those latter two cases, you want essentially as you go from the jam session to the semi-improvised performance to the recital, you kind of go further into the unusual stuff and more of the storytelling, which I will get to in a moment. Oh, there's one more point I wanted to make here, and it's kind of a small point, but I'm just gonna throw this in here just because I wrote it up in the write-up, and I'm just taking these bits from here. Is to talk about tool support. And my main point here is actually mostly just to say that tools don't really support this very well. And it's kind of amazing that, let me see if I'm scrolling off the screen. No, I think it's all visible. It's kind of interesting that there are a lot of data analysis tools and there are a lot of presentation tools, but they do not meet. And that is true whether you have charting abilities in your slide tool or not, because if to make charts in Google Slides or PowerPoint, you have to bring the data over, and it has to be reshaped usually. You can't just talk directly to your database because it's going to look very, very different. You need aggregation, you need filtering, and all kinds of stuff. So it's almost impossible, unless you have a very small amount of data that you can just copy over to, or very well prepared spreadsheets, I guess. You might do it from there, to make charts in these presentation tools. And then they're not interactive. They're just charts. And so it's really hard to bring these charts over. And then because these meetings tend to be recurring, well, not just because of that, I guess, but they tend to have certain cutoff dates. So usually you want to know that this is data as of this date. And so you want to make sure that your data is up to date and it is correct and everything is consistent. And so what people do is they go through their presentations and replace all the charts. And it's just, and very often these have a lot of charts in them. And so you end up with like a lot of copying and pasting over and like screenshots and all this stuff. So it's just an incredibly painful and time-consuming process that is kind of staggering that there isn't better tool support for this kind of thing. So it's kind of an interesting thing to note. This is part of the paper, sort of like calling for that to be improved. But that's just a thing that I wanted to bring up here because it is quite interesting that there isn't a whole lot for that. All right, and then I want to see if there are questions on this or any comments. I'm going to have to keep my ranting on storytelling short because I'm a little bit over time already in my plan here. So then the next point I want to talk about is, actually not this one, but about storytelling very briefly. So I have a little bit of a write-up in the a few notes in the write-up, I should say, in the notebook for today. And one of the main things is, or the main thing here really is a little structure for stories that I want to talk about very briefly, because I think it's useful, even though it's very, very simple. Maybe that's why it's actually kind of helpful. So this is a piece from the New York Times from a number of years ago. This might be from 2012 or so. I'm not sure. I'm not seeing this here right now, but this is a fairly old piece, but I still like it, and I think it's a good example of a simple data story that is structured in a very specific way that I think is helpful as a general sort of template. So what this does is, and you have to kind of ignore all of these bits here, but this is just the live New York Times website. This is part of a larger story that talks about the tenure pipeline at Harvard Business School. And again, this is as of probably 10 years ago. And it starts by making a statement. And so my point here is that you want to start off a presentation with a framing device. That can be a question, that can be a statement. And so in this case, this says Harvard Business School says it wants to improve the gender balance among faculty members, but it is far from that goal without extensive hiring. So that's a claim, right? So we just made a claim here. So this, by the way, this was done, I believe this was done by Hannah Fairfield back in the day, 2012. So she makes this claim here to say that Harvard Business School, and I need to point over here, Harvard Business School needs to hire more women because their gender balance is off. And you can look, and what we see here, oh, by the way, this is actually a unit chart. So this is the number of men and women on the faculty, and it's represented by each individual being one dot. So actually, it's more of like a packed chart. It's not really a unit chart. Anyway, but this is a good representation because it's simple and you can easily see the difference. So we can see that there are a lot more male members here than female. And what happens here now is that she breaks this down into essentially by filtering on two different dimensions. So what we're seeing now is the tenured male professors and how long they have been at Harvard Business School. And so this is the number of years. It's kind of impressive. Somebody has been there for 51 years, but this gives you kind of a sense of this distribution. The distribution itself actually isn't important, it's not very important, I guess, but it's part of the story. So it's basically breaking down the data now. So we saw all the data first. Now we've zoomed in to just this subset of male and tenured. And then we can look at the tenured female professors, and we can see that there are a lot fewer. And which is, of course, not surprising because we saw that overall there are a lot fewer women than men. But of course, I don't know how much you know about the tenure process, but so you come in as an untenured junior professor, associate, assistant professor rather, and then at some point you apply for tenure, and then you might or may not get tenure. So important, of course, here is the pipeline. How many untenured faculty are coming in, and that some of whom will presumably turn into filled dots here, into tenured faculty. And it's also kind of impressive and sort of like depressing to have somebody there who's been there for 50 years who's untenured. But again, this is academia. But we can see that there are a lot of young professors here, or presumably young because they have been there for a small number of years. Male professors coming into this school, and some of them will get tenure there. So this is now a different slice of the data. We're now looking at, we looked at tenured men, tenured women, and now we're looking at untenured men, and now we're going to look at untenured women. And we can see that this pipeline, and this is also being shown here was this, or made as an argument, that says that the pipeline for women is small. And you can see that because you can see that there are a lot fewer than men. And the relationship is even, I'm not even sure if it's the same as for tenured, because it looks like there are not a whole lot of untenured women coming in here. So this is making an argument. This is not purely just showing you a bunch of bar charts here or whatever of data. This is very much structured around this argument to say that Harvard has apparently made some statements at that point to say that they want to improve their gender balance on their faculty, but they don't seem to be doing enough because we're not seeing a process that will lead to this. And so the structure here, let's see if I have this paper open or not. Yeah, so the structure, I had this short paper a number of years ago that is called an argument structure for data stories, because I was looking at a number of papers by a guy called Neil Cohn who does work on comics. And there's a lot of interesting sort of theory around comics and sequential presentation. If anybody knows Scott McCloud's book, Understanding Comics, very, very highly recommended. It's a really good book that I think is really valuable also for better storytelling with data, even if you're not using comics. But the structure here that I'm talking about is, and so this is the same example here, is that there's a claim, there are a number of facts here being presented, and then there is a conclusion, and the conclusion has to tie back directly to the claim. And just looking at this, I mean, it's kind of obvious that this is what you do, but it's just not very common for people to actually do, because, and this is kind of but I'm trying to show this here, is what's called the inverted pyramid structure in journalism, is that you essentially talk about what your conclusion is first, and then you just present facts, and then, but there's really very little sort of tying back things to that conclusion. So this is more of a raising a question, getting people's attention by saying, so here's a claim, or here's a question, and then you walk people through these facts, and then your conclusion, of course, has to tie back to that. So you're not just like sort of like saying, well, it's up to you to decide. No, you make a point here, you make an argument, and you want to make sure that your conclusion ties back to that claim or that question at the beginning. There are the examples, and I'm just going to show you the structure here because walking through them is going to take too long. But you can do this not just because, of course, what I just showed you is very simple. It just has 4 steps in it. But if you have more steps, if you have more pieces of data, you could just break it down into subsets. And this is what this particular piece does: is it has a claim. So basically, this is asking a question. It's called "What's really warming the world?" And they're basically looking at models of different causes. So is it the Earth's orbit? Is it sunspots? Is it volcanoes? And then they tie those things together to say, well, no, all the natural factors taken together don't actually do enough, combined, don't have the same effect that we're seeing in global warming. And then they look at human cost issues like land use, ozone, and so on. And then they basically say, well, yeah, this actually shows is a much closer fit, and then they combine all the factors to say, yeah, if we take everything together that we've just seen, then we can see that this is actually what's causing this. But the biggest impact, and this isn't very clear from my structure here, but you can see it in the charts, is that the clearest match to what's happening is greenhouse gases, and everything else is just sort of like making small blips here and there, but it's very small. So you can make these kind of, you can use this structure sort of like in a repeated fashion, and think about how to build a story out of that. And again, this is really simple. Like, all of me trying to explain this feels like it's just way more explanation than it really warrants. But just thinking of that helps to structure your presentation much better, I think, than if you don't do that. Right, so very briefly, I'll look at the comments. Okay, I appreciate those comments, but I don't see any questions, so I will move along here because there's at least one more. Yeah, so uncertainty is a bigger topic. I want to get and Simpson paradox. So we'll see how far we can get today, because I am way over my time. All right, so uncertainty. So uncertainty is an important topic in principle, but it's very, very kind of underappreciated, or like it's usually not done very well in data visualization. But there has been some work in sort of recent years, or the last, I would say, 5 years probably now, that has really shown some really interesting approaches and shown that they work really well too. So here's a quick sort of like idea of what uncertainty means and what it could look like. very often when you have a measurement or if you have some sort of sample, and this includes things like surveys and other things, you can have a model that tells you the error bars. Well, I already call them error bars, I guess, but the error that this lives in. Because if you sample some number of people or ask some surveys some number of people or sample some number of things that you measure, you're just getting a sample. You're not getting the full numbers, and we tend to be a bit too kind of hung up on like these individual numbers. But really, what we have to think about it in a more kind of statistics kind of way. So this is coming from the statistical kind of thinking, where you take a sample of some sort, and then figure out what that distribution probably looks like, and how likely you think your sample is actually the true value, and then you represent that in some way. And so here are two ways that are common. One is that you show the mean of that distribution, and then you show an error bar. And error bars have lots of problems, partly because very often you don't know what the error bar actually represents. It's typically a standard error, but it doesn't have to be. It could be a confidence interval, and those are all different because they cover a different part of the distribution. You can also show what's called a violin plot. So this is basically the distribution, the probability distribution function, the PDF. So the probability distribution along the values, but because the value axis is vertical here, it makes this kind of vertical thing. And the violin plot is just basically the same thing as that kind of hump that you know from the standard deviation probably, or just kind of the standard distribution, the normal distribution. That's the word I'm looking for. So if you think about the typical normal distribution kind of representation, which I can show you here, right? So this is what that looks like. This is a density plot here. The violin plot basically just takes that whole thing and makes it symmetrical around the axis. And these are common in the literature, but they're actually also not very good because it's hard to read this. Most people so the fact that it's symmetrical actually makes it hard to read, and then most people don't understand. Essentially, most people just go with the max here and say, well, this is probably the value, and don't really understand the shape of the distribution all that well. And in this particular paper that I'm zooming into here, this is about a technique called hypothetical outcome plots, or HOPs. And HOPs are one of those newer techniques. This was proposed by Jessica Hallman in 2018, I believe. And no, it must be older than that, maybe more like 2016 probably. And the idea here is actually to do something different, which is to sample from this distribution and then show individual values as, in this case, a line that hops around. So this is kind of a pun on that acronym. But the point, the lines that you see are denser in the area, or there are more lines in the area that is denser in the distribution, and fewer where you're going towards the tails. And so that should give people a sense of that distribution. And I'll get to this. So they tested this, and it actually works quite well. It doesn't. A lot of people don't like that, but it works quite well. Another way of showing this uncertainty are these kinds of plots. So there's the density plot, which is sort of like the standard. This is what people have been doing for a long time. Then there's this idea of the stripe plot, where you just show a lot of samples and possibly even all your data points if you don't have that many. But because you're only showing this on one axis, you just show these sort of like lines for that. Then there's what they call the density and stripe plot, where you basically just cut out the shape out of this stripe plot. So you just take this and basically mask it so that you get this distribution here visible as well. And that's the interesting bit, you can also take this distribution and resample it at like certain intervals here, and then take a fixed number of dots and represent, or sort of like approximate the distribution using those dots. And so you can do this with like some number, 20, 50, or 100 dots. And what's really interesting about this, and I have this sort of summary of this. And this is from a paper, by the way, that is, I really like this title. It's called "When-ish is my boss." So when-ish is my bus, which is about this one bus away app that people in Seattle are very familiar with, because it tells you when your bus is coming, and it shows you the uncertainty there. And so they did a study on like how well can people reason about that information when they're shown the same data using these different techniques. And what they found, this is just another example here. Sorry, I have that image in the write-up, but here, maybe I'll just show you this. I just also like this paper. This is Matt Kay's work, and they just do this amazing work here where they just annotate these result charts, which is pretty unusual in the scientific literature, but it's just such a good idea. But basically, what they found here is that the best representation is actually the 20 dot plot, which is really interesting because it makes you would assume that more dots are better because you get more resolution, but it's not the case. People seem to get confused by that. But people actually did really well with the 20 dots and not as well with the other ones. And it's not just that, but also like how they sort of felt about their confidence, that's the word, their confidence that they had was lower with these other techniques. So it was really interesting to see how it's somewhat counterintuitive that people would be able to work with fewer dots and be better than with more. And then I think I have to and then this is my last paper that I want to talk about. And again, these are all linked from the write-up. These papers here, especially this one and the one I just showed you, are very readable, I think, and especially if you just look at the pictures, basically these figures are very good, and they very nicely show this sort of like the outcomes very well. And then this is another one. This is probably the best summary of this work, at least up to that point, which I think is about 2 years old, that shows a few different sort of ways of showing uncertainty here. So one is showing these sort of like 95% containment intervals. Oh, and since I want to bring up this question real quick. So this is a good point. Between error bars and violin plots, there could be box plots. So box plots are another one of those things that they have a very sort of like long history, and if you've ever used one, you may know what they are. But they've been shown to be really, really hard to read. Most people don't understand the interquartile range because they show the mean, the interquartile range, and then I don't even know what the outer bars are. I think it's a 95% interval, and you end up with, it's just really hard to read that as a distribution. Like what did the boxes mean versus the mean value. And what they've also found in this study here is, so they have each of these charts here, they have a version that shows the mean as a line, basically. Yeah, all of these have lines, I guess, for the means. So if you show an extent, and so in this case you see 95% confidence interval for this one, and do the same thing with the line for the mean, you get a very strong sort of attraction force towards the mean. So people just tend to just take a shortcut and just say, well, yeah, it's just the mean. So this is the most likely value, but it's not. I mean, it is, but it's not. That's not the only thing, because you do get you have a distribution. There's a lot more going on here, and so they tested these different techniques against each other. So this is sort of like the standard. This could be a box plot too. I don't think it matters all that much, honestly. The hops, so again, the animation over time here of the value bouncing around according to the distribution. Then they have the density function, which is, again, this common one that people have probably seen. And then the quantile plots, which are the ones I just talked about. So 20 dots that represent this the distribution. And again, they found that the dot plots did the best. People just had the highest confidence, best performance, and just basically just made fewer mistakes than with the other representations, which is pretty interesting. It's kind of a fun thing to realize that these plots, even though they show less data in a way, because there's obviously quantization, so you get a lot less resolution than like from these guys, people do much better with these charts than the other ones. And so uncertainty, there's a lot more to uncertainty, because this is essentially one-dimensional uncertainty here. If you have a lot more than that, you're gonna, or multiple dimensions that you want to show, this gets much more difficult to do. But at least for this kind of thing, for a representation of a value and specifically showing uncertainty, it's actually there are really good techniques now that can be used for that. There's also, and I have this in the write-up very briefly, sometimes people just assume that because you're talking about uncertainty, you want to just kind of blur things out. There are some studies that show that looked at that, and they've all been basically a big failure. And I know why, because I did some work more than 20 years ago now on using blur and sharpness, just like in photography, or like in this video. Like if my face is in focus and the stuff behind me is out of focus, which focuses your eyes or directs your eyes to something, but we're very bad at gauging the difference in focus. Like it's my hand here in front is blurred relative to my face, but you can't tell how much that is. Like if I move my hand, it gets sharper, but you're not going to be able to quantify that. And so we're really bad at quantifying blur. So it's just not a way to do this. That's going to work. I've tried it and failed. So yeah, this is an interesting idea. I don't know if that would work. This is, further studies are certainly needed. So I find the stripe plot the easiest to read. How about that coupled with an area chart showing standard deviations? I don't know. Would be worth trying out. I don't think that has been tested, not that I know of, but that doesn't mean it hasn't been done. Right. Okay. So again, this is a big topic. There's a lot more going on there. I'm linking to a bunch of these papers if you want to know more. These charts are actually there is a grammar of graphics for this kind of thing for charts in R, but they tend to be difficult to make. We should really look into how to make them unobservable. But there are some tools, but they're not very common yet, because this is still fairly recent research. Okay, and with that, I'm going to skip over the Simpson's paradox. I'm going to talk about that next time, and talk about ISOTYPE very briefly and unit charts. So ISOTYPE or unit charts are an interesting topic to me, because I think they're just an interesting idea that is also a difficult thing to capture in a grammar of graphics, unless you have a very specific one just for unit charts. And I think that exists, but for general grammars of graphics, it's really hard to capture them. So the idea behind unit charts is that if you want to have images in your charts, and we'll get into that, why you would do that in a moment. But if you do that and you scale your images, then you get this problem. This is from a very old book by Otto Neurath. Just basically argue why you want to do unit charts rather than scaling, because this is the number of marriages in the 1910s and 1920s in Germany. There we go. and if you use this sort of icon for this couple and you scale it like a bar, you would only stretch vertically. So this would look really weird, because they would be either stretched like crazy or like compressed like crazy, depending on the aspect ratio, I guess. So what people do is they scale the image, but now you're scaling in 2 dimensions, because as this gets taller, it also gets wider, right? So now this looks like much, much larger. This looks a lot bigger than this, even though the factor here is 2. It looks more like 4 times, because you got 4 times the area. And so Neurath's point was that why not instead use a multiplier and represent the number as a small icon, essentially. And so there's now I'm not sure exactly why these numbers are so different, but okay, so this is hundreds thousands, so there's no multiplier here. So this is some multiple here that isn't specified. But so one icon, one sign here, one mark represents 100,000 marriages. And so this is actually a different chart here, really. But you can essentially multiply this. You can read. So this is 5. So it's about 500,000 marriages in these years, 1911 to 1914. Oh, because these are ranges, I guess. These are individual years. But this must still be thousands here. And so you essentially can read this as 2 different things. You can read this as bars, because there's a length of each of these. So this bar is longer than this bar, and then this bar is longer than that. But you can also read this as by actually reading off the number and multiplying that. That's why the multiplier is there, because that way you get a sense of the value. It doesn't give you a precise number, of course, but then even a bar chart isn't going to give you that. And the reason for using these icons, so these were designed by Gerd Arndt, who is very, very famous in design circles, because he designed all these like iconic icons, I guess, like these things that that have defined the kind of visual language of sort of modernist representations of all kinds of objects for a very long time. So in this case, this is looking at technology, I guess, in the 1930s, 1937, how many motor cars, telephones, and radio sets people had in different countries in 1937. And the icons here tell you what they are, right? So you don't need labels. You can just see these are cars, early times cars, but still, and a lot more in the US than in the other countries here. How many phones people had. And again, these are very old times phones, of course, and then radio receivers. These were a new thing in the 1930s. So this was a thing that you can now compare and very easily like read this sort of like grouped bar chart and still get a sense here. Oh, there you go. So per 50 population. So this is the actual number. So each one is 1 per 50. So that's why there are these 50 people being represented here. So this is normalized by population. And the interesting thing about this, and so a unit chart in general is just the same thing, but not with images, right? So you take a number, so you count the number of couples getting married here, and then you have some number like 543,000 in that year, and then that number gets turned into a multiple of this mark, which is why it's so annoying to do this in most tools, because they don't like having multiple marks represent essentially a single number. So that's where this gets tricky. So I just wanted to show you this very briefly, and we're pretty much at almost at time here. So I'll just close with this. So this is a very simple isotype-ish chart in observable plot, and I'm showing you this because there's a little trick here. But so this is made up numbers. This does not actually represent anything real. Oh, actually, I do want to show you one thing very briefly here. So we did this study. This is actually from a paper where we compared different types of representations, bar charts. Oh yeah, this is a unit chart. So this is just a unit chart that just shows dots here instead of icons. The isotype-ish chart here, or isotype chart, I should just call it isotype. There are small differences, it doesn't matter. And then scaling the objects. So this is just the same objects, but scaled, the same icons scaled, but scaling both dimensions, because otherwise they would just be stretched like too much and even hard to read. And then we had this sort of like chart trunk version here, where we just have an image in the back, and then we had labels. Or image labels. And what we found was that people actually remembered the isotype chart the best out of all of these charts, and it was easier for them to remember what it was about. And I think that the reason we think it is because they were looking at the icons the whole time. Because here you have to look at the icon to find the label. Here you have to look at the text to find the label. So it's much easier to remember these things when they are icons and look like the isotype chart. Of course, this means you have to have actual objects that are different. Like if this is all, I don't know, mobile phones that all look the same when you have them as little icons, you're not going to be able to tell them apart, or other things that are much more sort of abstract. So this doesn't always work, of course, but it can work at times, and it can make it easier to remember things. And especially if you can use something like these emoji here in this chart, where it's just, this is made up again, so you can use whatever you want. You could use, I don't know, maybe you have survey results and you show like, I don't know, different kinds of smileys and frownies for that. But these are supposed to show millions here, so each one here is a million. And you can show data that way. You can compare, between Great Britain and the US. This is the kind of thing that you would find a lot in like these books in the 30s, not so much, but then 40s and 50s. This was used to kind of educate people about all kinds of things, about different places in the world, and sort of do this through data, which is kind of interesting. But what's fun about this, I just took this from the plot documentation, is that there's a bit of a trick here, because plot also doesn't actually want to do this repetition of marks, but you can get around that by using a text mark. So text is also a mark type in plot. and then just making a string that repeats that animal. So this basically grabs the animal from an array that has the emoji in it, and then looks it up by name, and then repeats it the number of times that you want. So there's a number here that we divide by 1,000,000. So 1e6 means 1,000,000, 1 times 10 to the 6. And then this gets rounded, and then we repeat that as many times. So each complete, I can even select this, even each sort of bar, each animal type is one mark here because they are text marks. So they're hard to make in most tools, but they are an unusual chart type. All right, so and then with this, I'm at time. So next time we'll talk about Simpson's paradox because I wanted to do this today, but didn't get to it, but it's in the write-up, so you can take a look. And then also we'll talk about time and the representations of time and all the things around that should be interesting. So tune in again on Tuesday, and I wish you all a good weekend, and see you next week.